Hello friends, in the previous video we have discussed with respect to nodal analysis and mesh analysis. Also we have discussed with respect to source transformation. In this video let us talk about Thevenins theorem. So the topics what I am going to cover is what is the definition of Thevenins theorems, what is the steps involved in order to solve a given problem based on Thevenins theorems. We are having three cases with respect to Thevenins theorem and we are going to solve problems based on Thevenins theorem. First of all, let us talk about the definition of Thevenins theorem. What is the definition states is, in any linear bilateral network consisting of n number of voltage source or current source, dependent and independent elements can be replaced by a single voltage source, and that voltage you are going to call it as Thevenins voltage, and an impedance looking from that end is called as Thevenins impedance. So this Thevenins impedance is represented by ZTH or RTH, and Thevenins voltage you are going to represent by VTH or VOC. So this VTH and ZTH is connected in series. Able to follow? Again I am going to repeat. In any linear bilateral network consisting of n number of voltage source or current source and dependent or independent elements can be replaced by a single voltage. That voltage you are going to call it as Thevenins voltage, and an impedance looking at the load end, that is called as Thevenins impedance. Able to follow? Now you are having a huge circuit. Say suppose only one element is varying. That element I am going to call it as ZL, nothing but load impedance. So rest of the circuit is static part. So the entire static part is a bilateral network. This one how can I replace is, I can replace by a single voltage source, that is Thevenins voltage, and an impedance called as Thevenins impedance. These two things are connected in series. To this we are going to connect load impedance and then we are going to solve. Right? So these two things are static part which is not going to vary. Based on load you are going to calculate what is the value of load current IL or what is the open circuited voltage. Able to follow? Next we are having three cases. The first case is when the circuit is excited by only independent sources, and the second case is when the circuit is excited by both dependent and independent sources, very important. And the third case is circuit energized by only dependent sources. If you are preparing for NET exams, case 1 is very important when you are preparing. But if you are preparing for exams like GATE and ESC, then case 2 and case 3 is questions are very important. Able to follow? Next, let us talk about case 1. What does it states is when the circuit is excited by only independent sources. Independent sources here means it's a practical voltage source and a practical current source, right? So a linear bilateral network, how you are going to replace this? You are going to replace by a single voltage. That voltage you are going to call it as Thevenins voltage, and an impedance you are going to call it as Thevenins impedance, and you are going to connect a load impedance across it. Able to follow? Now let us solve a problem based on case 1. What they have given is, they have given an independent source 4 volts. It is a practical voltage source, and 4 ohm resistors. Again 4 ohm is connected in parallel. Again 1 ohm resistor. You are having a load resistance of RL, that is 2 ohms. First step is you have to remove the load impedance. You have to remove the load impedance and you have to calculate the open circuit voltage, nothing but VOC or VTH across this terminal A and B. So across this terminal A and B, whatever the impedance they have given, just remove the impedance and calculate the open circuit voltage, that is VOC. So this anyway this path is open circuit, no any current will be flowing. So I can tell current through 1 ohm resistor is equals to 0. Current through 1 ohm resistor is equals to 0. At that time this node will be my open circuit voltage or Thevenins voltage. Right? So we are having two principal nodes. The first principal node is this one and the second principal node is this one. So one of the principal node need to be connected to ground. Before applying nodal analysis, we have to connect one of the principal node to ground. we are having 4 simple node. This is first simple node, this is second simple node, and this is third simple node, and this is fourth simple node. So principal node, one of the principal node I have connected to ground. For rest of the principal node, you have to apply KCL, nothing but Kirchhoff's current law. Let me apply Kirchhoff's current law. I am going to assume all the currents are leaving this node. All the currents are leaving this node. Let me call this current as I1, this current as I2, and this current as I3. What is I1 plus I2 plus I3? It is 0, because algebraic sum of currents at a node is equals to 0 based on Kirchhoff's current law. How can I define I1? I1 equals to VTH minus 4 divided by 4. VTH minus 4 divided by 4, because I am going to assume current is flowing from right to left, plus what is the value of I2? I2 is VTH divided by 4 plus what is the value of I3, which is 0, So I will be getting 2 times of VTH minus 4 equals to 0. So I will be getting VTH equals to 2 volts. Able to follow? Next, I have to calculate the Thevenins impedance looking at this end. Looking at this end, I have to calculate Thevenins impedance. In this case, all the elements are resistance, so I have to calculate Thevenins resistance. So the circuit what I will be getting is 2 ohms over here and 2 ohm over here. In order to find or in order to calculate this Thevenins resistance, if you are having voltage source, make sure you are going to short circuit the voltage source, and if you are having current source, you have to open circuit, right? So in order to find Thevenins impedance, nothing but ZTH or RTH. What is the first step is, you have to make sure all the voltage sources are replaced by a short circuit, and the second one is, if you are having current source, make sure you are going to do open circuit, and then you are going to calculate the equivalent impedance. Able to follow? Next, so the voltage source I am going to replace by a short circuit. So rest of the circuit is, you will be having 4 ohms over here and 1 ohm over here. This is the terminals, that is A and B. So looking at this end, you have to calculate the value of RTH. So how can I define RTH? As RTH equals to, this 2 ohms and 2 ohms are connected in series. So the equivalent value is 4 ohms, which is in parallel with 4 ohm. This entire block is in series with 1 ohm. So I will be getting 2 plus 1, which is equals to 3 ohms. So 2 plus 1, which is equals to 3 ohm, because whenever the resistance are connected in parallel, so how can I express this? 4 into 4 divided by 4 plus 4. If 2 equal resistance are connected in parallel, then the equivalent resistance is half of the original resistance. So how can I replace is, I will be having a Thevenins voltage, that is VTH equals to 2 volts, and the Thevenins resistance I am going to call it as RTH, which is equals to 3 ohms. So this is the equivalent circuit. So initially I have removed the load impedance, so I have to connect back my load impedance, that is 2 ohm resistance. Able to follow? So this is the equivalent circuit, or this is the end product of the circuit. So if they are asking you to calculate what is the value of load current, so how can I calculate the load current? Load current is given by VTH divided by RTH plus RL. So what is the value of VTH? Which is 2. What is the value of RTH? It is 3 plus 2. So I will be getting 2 divided by 5. So I will be getting IL equals to 0.4 amperes or 400 milliamperes. So given huge circuit, how I am going to replace is, I am going to replace by your Thevenins voltage, that is VTH, and the Thevenins impedance, that is ZTH or RTH, and I am going to connect back my load impedance, that is RL or ZL. Able to follow? In case 2, the circuit is energized by both dependent sources and independent sources. So the independent sources are voltage source and current source. But in the case of dependent sources, you will be having voltage controlled voltage source, voltage controlled current source, and you will be having current controlled voltage source also, or current controlled current source. So these are all my dependent sources. So the entire bilateral network I can replace by a single Thevenins voltage or a single voltage source. That one I am going to call it as a Thevenins voltage, and an impedance looking at that end, that is Thevenins impedance, and the load resistance. All these three things are connected in series. All these three things are connected in series. Since you are having an active elements or dependent elements, you can't calculate the value of ZTH directly. So in order to calculate the value of ZTH, what you are going to do is you are going to calculate VOC divided by ISC, nothing but open circuit voltage divided by short circuit current. This open circuit voltage is equals to Thevenins voltage, is equals to Thevenins voltage. Able to follow? Now let us solve a problem based on case 2. So if I want to calculate the value of VTH, first thing what I have to do is I have to replace this load impedance or load resistance. So the load resistance terminal, I am going to call it as A and B. I am going to call it as A and B. What is the first step? What is the first step? You have to remove the load resistance. So the left out circuit will be 1.6 amperes in parallel with 100, and in parallel with you will be having a dependent source, that is voltage controlled current source. You will be having voltage controlled current source, right? So anyway, this 50 ohms I have removed. So you have to calculate this open circuit voltage, or this is Thevenins voltage. So in order to calculate this Thevenins voltage, what I am going to do is I am going to apply nodal analysis. So this terminal is a node. So this terminal and this terminal, these two terminals are same, nothing but these two are a common node, and one more node is this one. So I am going to connect it to ground. So I am having two principal node, out of which one I have connected to ground. On the other one I am going to apply nodal analysis. I am going to apply nodal analysis. I am going to apply nodal analysis. What I will be getting is, let me talk about this current. This current is opposite to that of 1.6. So I will be getting minus 1.6, plus this current is voltage divided by impedance, nothing but VOC divided by 100. You can write it as VTH also. So VOC equals to VTH in this case, plus this current is 0.02 times of Vx, which is equals to 0, which is equals to 0. This voltage is same as VOC or VTH, so I can replace this Vx as VOC. If I am taking LCM, I will be getting minus 160 plus VOC plus 2 VOC, which is equals to 0. So what I will be getting is 3 times of VOC, which is equals to 160. So I will be getting VOC equals to 160 divided by 3. I will be getting 53.33 volts. So I will be getting 53.33 volts. So this is the value of VOC or VTH. Now if I want to calculate the short circuit current, so what I have to do is I have to replace this 50 ohm by a short circuit. So when I am going to replace by a short circuit, that current I am going to call it as short circuit current. So you have to calculate this short circuit current. So what is the value of this short circuit current? So this entire 1.6 amperes will be choosing this path only, will be choosing this path. So when it is a short circuit, at that time Vx will be equals to 0 volts, because in a short circuit path voltage will be 0, ideally I am speaking. So this entire 1.6 amperes will not be flowing in 100 ohms. 1.6 amperes of current will be choosing this 50 ohms path, right? 0.02 times of Vx, which is equals to 0. So I will be getting short circuit current, which is equals to 1.6 ampere. I will be getting short circuit current, which is equals to 1.6 amperes. So how can I define ZTH or RTH? So the Thevenins impedance, how can I define is which is equals to VOC divided by ISC. What is the value of VOC? It is 160 divided by 3 into, what is the value of short circuit current? It is 1.6. It is 1.6. So I will be getting 100. I will be getting 100. So the Thevenins resistance, which is equals to 33.33 ohms. 33.33 ohms. Final circuit, how can I write? I will be having a Thevenins voltage or open circuit voltage, which is 53.33 volts, right? In series with, you will be having a Thevenins resistance, that is RTH, which is 33.33 ohms, which is 33.33 ohms. In series to that, you will be having a 50 ohm resistor. A 50 ohm resistor you will be having. Able to follow? Now, if I want to calculate the load current, how can I define the load current? Load current equals to, what is the value of voltage? That is 53.33 divided by total impedance is 50 plus 33.33. So I will be getting 83.33. Able to follow? IL, roughly if I am calculating, it is 0.6 amperes. Let me consider one more problem. So in this case, what they have given is, the load resistance is connected between A and B. At that time, your 10 ohm will be a load resistance, that is RL. And you have to calculate what is the value of open circuit voltage, that is VOC or VTH. Since there is no current that is flowing in this path, so the current is 0 amperes. So this node will be my VOC or Thevenins voltage, that is VTH. We will be having one more principal node. That principal node, I am going to treat it as ground. For the another principal node, let me apply KCL or let me apply nodal analysis. So this current is VOC minus 10 divided by 20 plus, what is this current? It is minus 0.1 times of Vx. 0.1 times of Vx plus, what is this current? This current equals to 0, which is equals to 0. But what is the value of Vx? Vx is the voltage drop across this 20 ohm resistor. So Vx is connected between 10 volt battery and VTH node. So how can I write Vx as? Vx equals to 10 minus VTH or VOC. Able to follow? So on substituting over here, I will be getting VOC minus 10 minus 0.1 multiplied by 20 is how much? 2 into, what is the value of Vx? Vx equals to 10 minus VOC, which is equals to 0. So I will be getting VOC minus 10 minus 20 plus 2 times of VOC, which is equals to 0. So I will be getting 3 times of VOC, which is equals to 30. So VOC equals to 10 volts. VOC equals to 10 volts. So I got open circuit voltage, that is 10 volts. Able to follow? Next, let me calculate the short circuit current, that is ISC. The short circuit current, that is ISC. Now look at over here. Whatever the current that is flowing over here, the same current will be flowing in this 20 ohms also. So this will be my short circuit current, that is ISC. So I have to calculate what is the value of short circuit current. So in order to calculate the short circuit current, let me assume this node as Vx. Let me assume this node as Vx, because we are going to consider this 20 ohm also. So this potential will not be equal to VOC, it will differ. So let me apply nodal analysis over here. Let me consider this one as Vxy, because Vx1 is one more terminal, right? So Vxy, let me take. So it is Vxy minus 10 divided by 20 minus 0.1 times of Vx plus this current is Vxy minus 0 divided by 20, which is equals to 0. Which is equals to 0. But what is the value of Vx? What is the value of Vx? In this case, now Vx is defined as 10 minus Vxy. 10 minus Vxy. So I'll be getting Vxy minus 10 divided by 20 minus 0.1 times of, what is the value of Vx? It is 10 minus Vxy, 10 minus Vxy plus Vxy divided by 20, which is equals to 0. Upon taking LCM, so what I will be getting is, I will not be getting 0.1, directly I will be getting 2. I will be getting 2. So Vxy minus 10 minus 20 plus 2 times of Vxy plus Vxy, which is equals to 0. So I will be getting 2 times of Vxy, 3 times of Vxy, 4 times of Vxy. So I will be getting 4 times of Vxy minus 30, which is equals to 0. So I will be getting Vxy, which is equals to 30 divided by 4. 30 divided by 4, which is equals to 7.5 volts. Which is equals to 7.5 volts. Now, if I want to calculate the short circuit current, that is ISC, which is equals to Vxy divided by the resistance that is involved in this path is 20. The resistance that is involved in this path is 20. That is 7.5 divided by 20 or 30 divided by 4 into 20. So I'll be getting 2 times 3 times. So I'll be getting 3 divided by 8. 3 divided by 8 amperes. So final circuit, what I'll be getting is, I'll be getting a Thevenins voltage which is equals to 10 volts, which is equals to 10 volts in series with, I'll be having a Thevenins impedance, that is ZTH. In parallel to that, in series to that, you will be having a load resistance, that is 10 ohms. That is 10 ohms. So what is the value of ZTH is my question. ZTH, how can I find? Since you are having active elements, with the help of Ohm's law, I am going to calculate the value of ZTH or RTH. What is the value of RTH? It is voltage divided by current. So what is the voltage? The voltage value is VOC or VTH, that is 10 divided by, what is the current? What is the short circuit current? Which is 3 divided by 8. Which is 3 divided by 8. So I'll be getting ZTH or RTH, I'll be getting 80 divided by 3 ohms. I'll be getting 80 divided by 3 ohms. So if I want to calculate the load current, that is IL, how can I express IL? IL equals to voltage, that is 10 divided by RTH plus RL, which is 80 divided by 3 plus 10. 80 divided by 3 plus 10. So I'll be getting, so upon taking LCM, I will be getting 80 plus 30, which is 110, and 3 I am going to send to numerator, so that is 30, which is IL equals to 3 divided by 11 amperes. So I will be getting IL equals to 3 divided by 11 amperes. So this is how we are going to solve case 2 problems. Let us consider case 3 problems where the circuit is energized by only dependent sources. Nothing but you will not be having any independent sources. Whenever you are not having any independent sources, at time t equals to infinity, you will not be having voltage, you will not be having current also. You will not be having voltage and you will not be having current also. So what you are going to do is, in order to calculate the Thevenins impedance, you are going to make use of a test circuit. So across these terminals A and B, you can make use of a test circuit. That is, if you are making use of voltage source, you are going to provide 1 volt. Say you can give 10 volts or you can give 100 volts also. Based on that, current will also be varied. So for my convenience, I have taken 1 volt, or you can inject even 1 ampere current also. Either one of the case you have to do. If you are applying 1 volt, then the Thevenins impedance, that is ZTH, is given by 1 volt divided by what is the value of the current that is flowing in that path. What is the value of the current that is flowing in that path, you have to calculate, right? Or you are going to calculate what is the value of VTH or VOC divided by what is the current that you have injected, which is 1 ampere. Which is 1 ampere. Voltage divided by current. Any one of the parameter you are going to assume, and then you are going to calculate. Able to follow? Next, In order to solve this problem, what I am going to do is I am going to make use of a voltage source valued 1 volt. I am going to calculate what is the current that is flowing over here. That current I am going to call it as a load current IL, or you can consider IS also. I am having two principal nodes. First principal node is over here and the second principal node is this one. We know that in the case of nodal analysis, one of the node should be assumed to be ground. That node should be a principal node. For rest of the principal nodes, you have to apply nodal analysis. Let me apply nodal analysis at this point. Let me consider this node voltage as Vx. All the currents are leaving. All the currents are leaving this node. All the currents are leaving this node. Now, applying nodal analysis at this point, I will be getting Vx minus 10 times of I naught. So, this current is Vx minus 10 times of I naught divided by what is the resistance involved in that path? It is 4 plus what is this current? It is Vx divided by 2 plus what is this current? That is Vx minus 1 divided by 1, which is equals to 0, which is equals to 0. So, I naught is the current that is flowing over here. So, I naught equals to what is the value of voltage? That is Vx divided by what is the resistance involved in that path? It is 2. I can replace I naught equals to Vx by 2. So, I will be getting Vx minus 10 times of Vx divided by 2 whole divided by 4 plus Vx divided by 2 plus Vx minus 1, which is equals to 0. So, I will be getting 5. So, what I can write is Vx minus 5 times of Vx. When I take LCM, I will be getting plus 2 times of Vx plus when I take an LCM, I will be getting 4 times of Vx minus 4, which is equals to 0. So, this 5Vx and 5Vx I can cancel. So, rest of the terms will be 2 times of Vx, which is equals to 4. So, I will be getting Vx equals to 2 volts. So, I will be getting Vx equals to 2 volts. So, I will be getting Vx equals to 2 volts. Now, I got Vx equals to 2 volts. Now, I need to calculate what is the value of I naught, nothing but what is the current that is flowing in this path. So, the current is given by, what is the value of Is? If I am assuming Is is flowing from right to left, then the potential should be 1 minus Vx. It is 1 minus Vx divided by what is the resistance involved in that path? It is 1 ohm, which is equals to 1 minus 2 divided by 1, which is equals to minus 1. But you have to take a magnitude sign. So, I will be getting I naught equals to 1 ampere. I will be getting I naught equals to 1 ampere. Why we have to consider magnitude? Because how I can calculate ZTH or RTH? So, how I can calculate RTH? RTH equals to what is the value of voltage that you assumed? That is 1 volt divided by what is the short circuit current? That is Is. Is equals to I will be getting minus 1 under modulus. Since the resistance can't be negative because each and every element is a passive element, resistance can't be negative. So, you have to take a minus sign. So, the final circuit will be VTH, which is equals to 0. So, you will be having an impedance, that is ZTH, which is equals to 1 ohm, and a load impedance that need to be connected over here. This is how you are going to solve case 3 problems. Able to follow? What are the limitations of Thevenins theorem? If the circuit consists of unilateral network, then Thevenins theorem is not applicable. Example, diode. The second demerits is there should not be any magnetic coupling between the load and the circuit. So, this is very, very important. Right? Given a huge circuit, you can replace by your single voltage source, that is a Thevenins voltage. In series with, you are going to connect a Thevenins impedance, you are going to connect a load impedance at last. But if there is any magnetic coupling between the load and the circuit, loading is going to take place, then you can't apply Thevenins theorem. So, these two things are the drawbacks of Thevenins theorems. So, in this video I have talked about Thevenins theorem. In the next video, let us discuss about Norton's theorem. Thevenins theorems and Norton's theorems are dual to each other. So in the case of Thevenins theorems, what you are going to do is you are going to write a Thevenins voltage over here in series with you are going to represent a Thevenins impedance. In series with you are going to connect a load impedance. But in the case of Norton's, you will be finding a Norton current, or you are going to call it as a short circuit current. In parallel to that, you are going to calculate the Thevenins impedance or Norton's impedance. So ZTH equals to Zn. So procedure remains the same. And in parallel to that, you are going to connect a load impedance, that is Zn. So I can tell Thevenins theorems and Norton theorems are dual to each other. So in this video, I have discussed 3 cases of Thevenins theorems and I have solved the problems based on this. In the next video, let us talk about Norton theorems. If you have understood with my lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. Thank you. All the best for your competitive exams.